3 times 10 to the 24th power molecules of fluorine. Knowing that our limiting reagent is the smaller of our two answers, let's not be tricked into selecting the 3.23. It's a smaller number, 3 is smaller than 5, but notice the powers. The 24th power is a larger number than a 23rd power. The maximum yield for this problem is the top answer, 5.58 times 10 to the 23rd. That makes our 195 grams of bismuth chloride our limiting reagent, and the 120 liters of fluorine as the excess reagent. The limiting reagent determines the maximum yield of our product, molecules of chlorine. I select the smaller of the two answers, a 23rd power being smaller than the 24th power. In part C, we are being asked to calculate how many moles of the excess reagent are left over, unused, wasted, sitting there at the end. As we do with all of our problems, we begin with the given amount in the limiting reagent. We start with the limiting reagent, 195 grams of bismuth chloride. This given amount is the limiting reagent. I am going to set up the three-step stoichiometry problem so I can get to liters of fluorine. The reason I'm going to set up all 3 liters is I'll need to subtract like units. Out of the 120 liters of fluorine we started with, I'm going to subtract how much was actually used. In order to subtract, I'll need 2 like units. I'll choose to convert both to liters. From there, I can do a mole map problem to convert it back to moles. In my first step, I will use 1 mole of BiCl3, which is our limiting reagent. We found its molar mass to be 315.5 grams BiCl3. We are making our target, if you recall, the excess reagent. We want to know the fluorine. So I go into my balanced equation for the heart of our problem. We want to know fluorine, its stoichiometric ratio of 3 moles F2. We set that over the limiting reagent, 2 moles of BiCl3, a 3/2 stoichiometric ratio. To land at a volume unit in our third conversion, I am going to use the molar volume number of 22.4. For every 22.4, we are using for fluorine in every 1 mole of fluorine. I'll divide, ratio, multiply, where the given, the start of my problem, is always the limiting reagent, and the target is the want. I want to know how much fluorine I used. I will hit 195 divided by 315.5 times 3 over 2. I'll multiply that answer by 22.4. 195 divided by 315.5 times 3 divided by 2 times 22.4. When I'm finished hitting all of that on the calculator, it reads 20.76. What this is telling me, the 20.76, is the amount of reactant that was consumed during our reaction. I'm not done yet. I need to find out how many was left over. It appears from our reaction we started with 120 liters. That's way more than we actually needed. Out of the 120, we only consumed 20.76 liters. I'll write that as the amount that was used. During the course of our reaction, reactants get used as products get made. We started with 120 liters of fluorine, and along the way we used up 20.76 liters of fluorine. I will now subtract those two numbers, 120 minus 20.76. And that answer gives me 99.24 liters of fluorine that were wasted, unused, in the reaction vessel. What I'm now able to do is think about a mole map problem. It ultimately asked me to solve for moles. Right now I'm at a liter. That's an easy exchange. 99.24 liters of fluorine. Using our mole map conversion, I'll just simply divide that answer by our 22.4 liters, and we'll have converted 99.24 divided by 22.4. And what I'm finding is 4.43 moles of our excess reagent went wasted. The final answer to letter C, reported in a mole answer, 4.43 moles. To recap the journey we just took, in part B from our balanced equation, we started with the known amounts of both reactants and targeted the product called chlorine molecules. When we found the product, I circled the smaller of my two answers, knowing that the limiting reagent gave me the maximum yield. Once I knew the limiting reagent, I also knew the excess reagent. In our part C, we always begin, as we always will, with the limiting reagent, and now we want to target the excess. The new target became the fluorine, not the product, but the other reactant. When we ended with our stoichiometry problem, that answer that we found told us during the course of our reaction, this is the amount that was used to make product. Reactants get consumed, they get used up. So I took the amount that we started with, that 120, and I simply subtracted the answer we just found. When I started with 120, and from the calculation found that we consumed 20.76 of that original value, I simply subtracted to find the amount that was wasted at the end of our reaction. That wasted amount, 99.24 liters, was then simply converted to the unit we were asked to report out, and that was the term mole.